Hello everyone, this is Shiv Kumar Seth. So today we are going to discuss probability. It's a very important topic for GATE point of view. So probability of any event is defined as P of A is equal to favorable outcomes divided by sample space. And favorable outcomes is indicated by M and sample space is indicated by N, where M could be here less than equal to N. So here, probability of any event that could be equal to 0 or 1 that happened only in case of biased coin. That is, both side is head or both side is tail. So first of all, we'll discuss your sample space, and that is defined as collection of all possible outcomes of an experiment. So, like if I'm going to toss a unbiased coin n number of times, the sample space is indicated as 2 raised to n. And if you substitute the value here, n is equal to 1, you will get the sample space 2 raised to 1 extra 2. Or n is equal to 2, the sample space will be 2 raised to 2 extra 4. So 4 means the sample space, it could be first time head or second time tail. The first time head, second time tail, or first time tail, second time head, or both the times it's a 10. Similarly, if you toss a coin n is equal to 4 times, the sample space will be 2 raised to 4 and it's a total 16 number of sample spaces there. But we are not able to write on all the 16 sample space. We have a trick to solve the problem based on the probability. So similarly, sample space, if I discuss for rolling of a die, so here rolling of a die n number of times, it's given as 6 raised to n. Why it is a 6 raised to n? Because there just 6 numbers are there in a die. And similarly, in an unbiased coin, there is a 2 raised to n. So there is a head and tail. That's why it's a 2 raised to n. So if you roll a die n is equal to 1 times, the 6 raised to 1, you will get the sample space is 1, 2, 3, 4, 5, 6. And similarly, if you roll a dice twice, so roll a dice twice or roll a dice, roll a 2 dice once. In both the cases, the sample space will be 36, and that is given as first time 1, second time also 1, first time 1, second time 2. So it will go on like 1 to 6, and similarly 2, 1 to 2, 6, and it will go on down, and it's a 6, 1 to 6. And it means the total sample space, I can say that yes, it's a 36. Similarly, we'll discuss the sample space for cards. So there is a 3 type of basic problem is there based on the probability. It's based on the coin, dice, and card base. So drawing a card from a 52 cards. So first of all, we have to know that what are the types of cards are there. So this 52 indicates that here total sample space. So in 52 cards, there is a 2 types of cards are there, 2 colors. That is the one is the black and the red. And black is 26, red is 26. Again, the black is divided into 2 types, spade and club. Spade is 13, club is 13. And similarly, the red is divided into 2 types of cards. It's a 13 and 13. That is a heart and diamond. So total, I can say that here 13 into 4, it will be here 52 cards. Now there is a 13 is the individual cards are there that start from ace. Ace, 2, 3, it will go up to 10, then jack, queen, king. So each card is 4, 4. So total it is a 13 is there. So 13 into 4, you will get it total 52. Now in that you have to know about the face cards also. What are the face cards? So we have a jack, queen, king. And each card we know that it's the 4 plus 4 plus 4. So total we have a 12 face cards. So remember that this 52 indicates that sample space. This 52 indicates that sample space. So we'll check the problem first of all based on the coins, because the coin is the basic problem and the mostly they will ask the question from the coins only. So we have a previous year question paper based on the coins problem. So here the 3 coins are tossed at a time. So whether you toss a coin 3 times or 3 coins a time, in both the cases, the sample space will be three. Sample space will be 2 raised to 3. So we need to find the probability of getting exactly 3. So here sample space, I can say that for n number of times it is given as 2 raised to n. So for 3 times it's just 2 raised to 3. It's 8. So see, we can't write down the all the sample space. If you toss a coin n is equal to 6 times or 5 times, then the sample space will be 2 raised to 6 and 2 raised to 5. 2 raised to 6 means 64 and 2 raised to 5 means it's a 32. But 32 sample space we can't write down. So what I'll do, I'm going to do it by trick method or conceptual method. So in the question, we have to find out exactly 3 heads. Yani there should be a 3 head. There should be a 3 head. It means I can say that try to find out first of all favorable outcomes divided by sample space. So sample space we got to know that it's 8. I need to find out favorable outcomes. See, I need here 3 heads. Meaning all the 3 times it should be it should be head only. So now this 3 head we can arrange it by how many ways? It's a 3 factorial divided by 3 factorial. If 3 letters are there, 3 letter we can arrange it by 3 factorial, and if all the letters are repeating, divide by that many number of times. So you'll get it here 1. So write down this one is a 1/8. बहुत ही tricky method है, very tricky method. So the option number 2 is right answer. Similarly, like next question is there at least 2 head. What is the probability of getting at least 2 head? So at least 2 head means there should be a minimum 2 head, maximum could be 3 head also. So try to find out the probability of getting x is equal to 2 head. Let us consider that x is a event and that is a head is there. So x is equal to 2 head plus probability of getting x is equal to 3 head. So x is equal to 2 head. It means 2 times head, 1 time tail. And x is equal to 3 head means all the 3 times it should be head only. So we can do it this one. See, this letter we can, or this word we can arrange it by how many times? It's a 3 factorial divided by head is repeating twice and the tail is repeating once. So this one I can write down, this one also we can write down in a combination format 3C2. The formula for this one is given as 3C2. So I can here apply the direct combination. Direct combination means if you want like 2 times of head, I will write down the favorable outcomes directly 3C2. So the answer will be 3C2 plus if I want a 3 head, the 3 head means it's out of 3 tiles, I need 3 head. So it's just 3C3 divided by sample space is 8. So the 3C2 value is a 3 and 3C3 value is 1. 1 divided by 8 is a 1/2. So I can say that finally the answer is 1/2. So if you are tossing a coin n number of times and if you want x number of times heads or tails, so we can say that NCX. Directly we can apply the formula. So similarly we have a question number 2. If a coin is tossed 6 times, find the probability that the number of heads turn up more than number of tails. So let us consider x indicates that number of heads. So I can apply that 6cx because we are tossing a coin 6 times. So I need here x number of heads. So 6cx. So sample space here I can say that 2 raised to 6 and it's a 64. I need to find out the favorable outcome. So first of all, write down the outcomes of an experiment. So see, 6C0 indicates what? So there is a 0 times head is there and 6 times tail is there. That is the meaning. 630 means 0 times head, 6 times head. Similarly, 6C1 means 1 time head, 5 times tail. 1 time head, 5 times tail. 6C2, 6C3, 6C4, 6C5, and 6C6. So I need to check it here. The number of heads turn up more than number of tails. So here I can say that here the head is 4 times, but the tail is 3 times. So this is my favorable outcome. This one. Similarly, 65 means the head is 5 times, tail is 1 time. This one. And here the head is 6 times and the tail is 0 times. So I can say that this 3 is my favorable outcome. So write on the favorable outcome 6C4 plus 6C5 plus 6C6 divided by sample space is 64, 2 raised to 6. If you simplify that 64, you will get the value here. It's a 50. 64 value is a 50 and 65 is 6 plus 66 is 1 divided by 64. And if you simplify, then you will get it here 22 divided by 64, and finally you will get it here 11 by 32. So we can say that the second option is right answer. So with the help of combination, the combination is very basics are there for the probability. We can apply directly to the coin case and even for dice case also. So these are the only basic things are there. I discussed that. So thank you everyone